Let's talk about finding the domain of a function when it doesn't model verbal conditions. It would always be the largest set of values, the largest set of real numbers for which the value of the function is a real number. Now, to do that, we need to exclude any real numbers that cause one thing is division by zero. So if you see division by zero anywhere in the problem, then you know that's not going to be part of your domain. And then we have to also exclude any real numbers that result in, and this is important, an even root, such as the square root of a negative number. So we don't want any imaginary numbers showing up. So I'm going to do 4 different things. I'm going to add 2 functions, subtract 2, multiply 2, and divide 2 functions. The functions are identified in each of the problems. I'm going to add some little titles here so that we can just do them in columns all the way down. And this one is going to be f plus g over here. And the second one we're going to work on is going to be f minus g. These are the functions f and the function g. And the third one will be, of course, f times g. And the fourth one will make f divided by g. Now, here's our 2 functions. F of x is x minus 1. F of g is x plus 2. If we wanted to add those two, all we'd really do is say, well, this is f of x, and we're going to add to that f of g. And now let's see what we end up with our new function. It would really be, we can sort of say it's y equals this. That's without function notation, of course, but it makes more sense to most of us. So let's see if we can add the x's. And I have 2 x's, so I'll have 2x. And negative 1 plus 1, of course, is plus 1. Now we look at that and we say, okay, we're going to exclude anything that causes division by 0, but there is nothing that's going to give me a division by 0. And anything that is a negative square root or a even root of a negative number, but there's nothing like that. So I can safely say the domain of this one is all real numbers. Let's do f minus g. Now, when we're subtracting a binomial, we of course have to put it in parentheses. So we'll say this is going to be y is equal to, I'll put out here, y is equal to x minus 1 minus, and then I want to include that second function in parentheses because I'm going to need to distribute the negative sign this time. So it'll be a minus x minus 2, and that gives me y, or my new function, is equal to, and my x's are going to go away, x minus x, and I'll end up with negative 3. Now, what possible values work for this? Well, anything would work for this. Any number I set in there, there's no issue of division by 0, no issue of an even square root of a negative. Multiplication. This time we'll say y is equal to, and this time we'll put both of our functions in parentheses because they're both binomials, aren't they? And we're going to have to FOIL this. So I'm going to say y is equal to x times x. That's going to give me x squared. I'm going to say x times 2, 2x. Negative 1 times x, negative 1x, if you will. And negative 1 times 2, negative 2. Let's combine all those like terms. We get x squared, and we get this is going to be plus x and minus 2. No division by 0 again. No even roots, right? No no even roots of a negative number. So I can say, okay, I've got another set of all real numbers. And what about this one? This is always where we have to be very careful, is when we have division of 2 functions. So this time I'll say y is equal to, and this is f of x would be x minus 1, and g of x is x plus 2. Now, I can't really simplify that. There's nothing that's going to simplify. So this is the final format of that function. And I'm going to look at it like this. I'm going to say, what would cause me to have division by 0? Well, if x was equal to a negative 2, I can't have that, can I? X cannot equal negative 2. There's nothing else. There's going to be no even square roots or anything. So I can list my set of numbers, if I will, as negative infinity, all the way up to positive 2, but not including, unioned with a positive 2 going all the way up to positive infinity. And the second one we're going to do is a little more complicated. When we do the f plus g, it looks like, I'll put y is equal to here, y is equal to 3x minus 1 plus, and this is going to be -9. I'm just separating the two signs there, plus 1. Since I'm adding them, I don't really have to put the whole function in parentheses. I don't have to distribute that plus sign, do I? Let's see what this comes up to be. I've got 3x minus 9x. I got a negative 6x. And then, of course, -1 plus 1, they just cancel. So what's going to cause me to have any of these problems, division by 0 or an even root of a negative? Nothing. I've got a set of real numbers again. Let's look at f minus g this time. So this time y would equal, and I can say 3x minus 1, and then I'd better include this next one in parentheses because I've got to subtract both of those terms. I'll distribute my negative now. And then I need to combine like terms. 3x, 9x is going to give me 12x. And I've got a -1 and another -1. That'll be minus 2. I'm looking for my two problems. Division by 0, it's not going to happen. And I can't find anything that's going to give me an even root of a negative number. So I'm going to say negative infinity to positive infinity is my domain. My next one, f times g. Well, this time y would equal my 3x minus 1 times my -9x plus 1. And I will FOIL. And I'm going to get a -27x squared there. I'll get a positive 3x when I do outside. I'll get a positive 9x when I go inside. And I'm going to get a -1. Now I'm ready to combine like terms. And 9 plus 3 is going to give me 12 minus 1. And that looks like it's the final format of my function, my combined functions, my multiplied functions together. Once again, I can go negative infinity to positive infinity because I don't have any of the two problems up here that I have to worry about. How about division? This one is always one I have to check for very carefully. I'm going to take the first function, f of x, divide it by f of g. And now let's see what we get. Well, one thing that will cause me trouble down here is division by 0. And to have this be division by 0, this term right here would have to be a -1. What would cause, what value for x could cause -9 times x to be -1? Well, I can look at it like this. I can say -9x equals -1, and I can divide both sides by a -9, and I get a positive 1/9. That's the number that's going to give me trouble. In other words, x cannot equal 1/9. If it does, this would be a -1. I would have division by 0. So what is my set of numbers for my domain? Well, it goes from negative infinity all the way up to 1/9. Doesn't include 1/9. And then it starts above 1/9 and goes all the way up to positive infinity. Let's take some that have some more difficult problems, some radicals in them. Let's say this one is going to be addition. So I'm going to say y is equal to the square root of x plus x minus 8. There's nothing I can combine or simplify or do anything with here. The problem would be if this number, this x value under the radical was a negative, I would have trouble. So I know it has to be 0 is okay, isn't it? Square root of 0 doesn't give me any trouble. So it has to be, x is going to have to be 0, greater than 0. It can be equal to 0, greater than 0, as long as it's positive. That's what my domain needs to say. So how would I say that? Well, I'm going to say it could be 0 all the way to positive infinity. How about subtraction? I'll say here y is equal to the square root of x. And I'll have to subtract two terms, so I'll put them in parentheses. Let's distribute those two terms, or distribute that negative. But we've got the same situation, don't we? What can x not be? Well, it can't be. It has to be greater than or equal to 0. X must be positive. So I'm going to say the same thing. I have that 0 to positive infinity domain. And notice that it can be 0. Square root of 0 just gives me 0. What about multiplication? This time y is going to equal the square root of x times x minus 8. Now, there's really no reason for me to distribute that. If I did, it would just get more complicated. I like to, when I'm trying to figure out the domain, I like to be in the factored form already anyway, and this is in the factored form. So I'm looking for any problems. And here's the problem. Same thing, isn't it? So I know once again, x must be a positive number or 0. And here's my domain. And let's look at division next. This time, my new function would be the square root of x divided by x minus 8. Now, I've got a couple of things that I see that might give me trouble here. I'm thinking that everything still has to be positive, right? I've got to be x greater than or equal to, I'll write it down, greater than or equal to 0. That takes care of this issue. But what about my denominator? What is the other number that x cannot be? X can also not equal the number 8. So how do I write that in my notation? Well, I'm going to start with 0, and I'm going to go all the way to 8, but I'm not going to include the 8. And then I'm going to join that with just above 8 all the way to positive infinity. All right, the last set of problems that we have down here are a little more complicated. Now, I hope I've left you enough room to write this. The first one we're going to take is to add these two together. And when I do this, I notice that I need a least common denominator. And when I look at the denominators for these two, which I know I'm going to have to do in these problems, it's going to have to be the sum of the two together. In other words, it's going to have to be x minus 1 times x plus 2. Now, I'll probably leave that format in my denominators when I get this done, but it might change the numerator, so I'm going to write it down for myself. And the first one I want to do is to add them together. So I'm going to say 2, I'll put y equals out here, over x minus 1 plus a negative 1 over x plus 2. And when I do that and I multiply both times that least common denominator, you should have done enough of this that you can see this happening. It's going to cancel out the x minus 1s, right? What am I going to end up with? Well, I'll go ahead and write it all over this same denominator. This will be my denominator when I finish. Now I just have to figure out what the numerators are going to be. So when I multiply 2 times the LCD, the x minus 1s cancel, and I have 2 times x plus 2. When I multiply negative 1 times this LCD, or negative 1 over x plus 2, the x plus 2's cancel, and I have negative 1 times the x minus 1. Now, at that form, I can start simplifying that numerator, can't I? I'm going to end up with y is equal to, and it will be 2x plus 4 minus x, or minus 1x, plus 1 over my x plus 1 times x plus 2. I'm sorry, there's not enough room for you to write. Next, let's finish this up. 2x minus x, what's that going to give me? Well, this is where I'm going to end up with just plain old x, right? See if I can get my video going again. Hang on just a second. Okay. So, what did I say? 2x minus x is x. 4 plus 1 plus 5. And like I said, let's leave that denominator in the factored form because it will help us to figure out the domain if it's already factored. Now, when I look at this, I don't have any square roots. I don't have any even roots, so I don't have to worry about even roots of negative numbers. I do have to worry about a x in the denominator here. It can't be a negative 1, and it can't be a negative 2, can it? sorry, let's go up here and make a correction. This one, of course, you notice should have been a negative. This should have been negative. This should have been negative. So x cannot be a positive 1. I'm sure you saw that before I did. So x can't be a positive 1, and x can't be a negative 2. Now, I could write that in my form that I use, and I'll see if I can do that for you here for my domain. I would go all the way from negative infinity up to negative 2, but don't include the negative 2. And then I'll join that with negative 2 to positive infinity. Oops, got to go up to 1, don't I? Sorry. To positive 1, don't include that positive 1, and do another union from 1 to positive infinity. And that'll take care of my two exceptions, negative 2 and positive 1. Let's do the next one. I wish I had more room for you. You might want blank paper at this point. I'm going to keep trying on this page. I'm going to see if I can add, subtract the two functions. So I'm going to say y is equal to 2 over x minus 1, and I'll subtract my negative 1 over x plus 2. Now, what I'm going to do is just distribute the negative to the numerator. So it's going to be the same thing as y is equal to 2 over x minus 1 plus 1 over x plus 2. All I have to do is get these to the common denominator of x minus 1 times x plus 2. So I'll multiply both of these fractions times that again. And I know I'll have that as my denominator. This time I'll try and get the negatives in the correct places. And this, all I have to do is say 2 times what part's going to cancel? Well, the x minus 1 is, so it's going to be 2 times x plus 2, isn't it? 2 times x plus 2 is 2 times x, and 2 times 2. And then this one is going to be 1 times x minus 1. Well, that's just going to be plus x minus 1. I think I've got this right, even though I'm trying to write it really, really small. I end up with x here, and 4 minus 1 plus 3 over x minus 1 times x plus 2. And once again, I have the same type of domain. I have the same issues here. And usually, I know the numerator getting these fractions converted and added together is a little bit tedious, but the problem is, the question is all about the domain. And this domain depends on that denominator since we don't have any roots in the problem. So we got the same denominator, and we got the same domain for this one. Let's see if we've changed things up at all with this next part where we're going to multiply. This time I'm going to say y is equal to, and it's going to be 2 over x minus 1. And I'll multiply that times a negative 1 over x plus 2. Totally different problem. I don't need a common denominator for this one, do I? But really what I'm going to do here is just leave it factored. I'm going to say 2 times negative 1. And then I'm going to have my denominator multiplied together, and I'm going to leave that factored. And it gives me, as you can see, the same situation, so I have the same domain. The final problem, and division is always where we run into trouble. If I come up here and I say y is now equal to 2 over x minus 1, and I have to divide that by a negative 1 over x plus 2, I'm going to change it to multiplication of the reciprocal. So I'm really going to say this is 2 over x minus 1 times x plus 2 over a negative 1. Now I can do some multiplication of that. And when I do, I end up with 2 times x. See if I can come down here and write it better. 2 times x is 2x. 2 times 2 is plus 4. And it doesn't matter. I could have left that factored into 2 times x plus 2, couldn't I? Because now all I'm going to do is multiply negative 1 times both of these. It's going to turn my negative 1 into a positive 1 and my positive x into a negative x. So I'm just going to write it backwards. So I'm writing 1 minus x. Now, this one is a little tricky because I can see from my answer here that x cannot equal a positive 1, right? That's going to give me trouble if x is a positive 1. I would have division by 0. But I have to go back to the original problem also. And I have to say there's another issue. Here's the same problem, division by 0 in the original problem, if x was equal to 1, but this one would cause me trouble too. X could be, or cannot be, a negative 2. So I not only had to look at my result, my answer, I had to go back to the original problem and see if there were any factors involved that were going to cause issues. Now, when I write this in my format that I've got, it's the same problem, isn't it? It can't be a 1 and it can't be a negative 2. So it would basically take the same format that I have over here when I write my solution. On page 31, we're going to do one more set of these problems just to make sure we've got it, and that's it. We're going to look at sum, we're going to look at difference, product, and quotient of these functions. So the first one I'm going to do is the sum. In other words, f plus g. I'm going to take the first one. I'll say this is y is equal to, let's add them together. 3x plus 2 plus x squared plus 6x minus 7. And then I'll do some combining here. I want the x squared term to be first. I'll take the 3x and add it to 6x and get 9x. And then I'm going to say 2 minus 7, negative 5. That is my final version. It looks like it's just going to be a very easy to figure out trinomial, right? And the thing is, I can look at this without even doing any more to it and say, I'm not going to have any trouble with causing division by 0, and I'm not going to have any roots of negatives. So the domain for this one, let's write our domain over here. It's going to be negative infinity to positive infinity, or we could say that's all real numbers, couldn't we? Let's do the difference now. The difference in the two of them, of course, is going to be the first function minus the second one. So my new function would say 3x plus 2 minus, and I've got to put this in parentheses because each of these terms has to be, the negative has to be distributed. I'm going to have 3x plus 2 minus x squared plus 6x. Was that a plus 6x? That was plus. This is minus 6x and plus 7. Y is now equal to x squared. I'll take my, I just have 3x, don't I, to combine with it? Nope, 6x. I've got a negative 3x, sorry. And I've got 2 plus 7 or 9. Okay, hopefully your algebra is better than mine this morning. And what do I have here? Well, no problems once again. No problems that I can identify for the domain. So when I tell the domain, I'm going to say it's the set of all real numbers again. Let's look at the product. So this product is going to be, of course, f times g. So what I want to say is this new function is going to be 3x plus 2 times x squared plus 6x minus 7. That means I have to multiply this quite a few times, right? I'm going to have to do 2 times 3. I'm going to have to do 6 multiplications and combine the terms. 3x times x squared is going to be 3x cubed. 3x times positive 6, 18x squared. 3x times negative 7, negative 21x. Now, let's multiply everything times the 2 times that trinomial. I'm going to write them underneath since I can match up the terms easier that way. I'll say 2 times x squared. Well, that gives me a 2x squared. It's a positive, right? 2 times 12x is a positive 12x. And 2 times negative 7, negative 14. I'm going to draw a line because I'm going to combine all these. And this is going to be y is equal to 3x cubed plus 20 x squared. This is going to be negative 21 positive 12 is going to be a negative 9x. and that's going to be minus 14. Once again, I see no restrictions on the domain. If I see no restrictions on the domain from my two rules that I'm following, I can say it is, once again, the set of all real numbers. And now let's do the quotient, which is where we always run into some problems. So we're going to be saying function of f divided by g, and that looks a little like this. I'm going to have y is equal to 3x plus 2 divided by x squared plus 6x minus 7. Now, when it's in this format, it's very difficult for me I can't reduce it, and I can't tell where my problems might be, where my restrictions on the denominator, so I need to factor. And always go to factoring first before you go to that quadratic, because the quadratic is the one that gives us so much more trouble, the quadratic equation. So I know that this is a plus minus. I know it's x plus and x minus. I know I need factors of 7 that will subtract to give me 6, and the only thing I can think of is 7 and 1. It needs to be a positive 6 or positive 7, negative 1, and I FOIL really quickly in my head just to check it. A positive 7 minus 1 gives me that positive 6, and I can see my restrictions on the domain. X cannot be, let's see, I'm going to write it like this. X cannot be a negative 7, and it cannot be a positive 1. So when I write my solution, it goes from negative infinity all the way up to negative 7, doesn't include it, joins that with just above negative 7, negative 7, going up to the number 1, don't include that one. And then I'm going to join it again with the number 1 all the way up to positive infinity. And I have completed my set notation there. And the next thing we want to talk about is what we call composition of functions. And the composition of functions is written a little differently. It's the first function, a little circle, and the second function. We call that f with g. So when we define the composition of functions, what we really do is we take the second function and we insert it into the first function. In other words, in this way this is written, we would be saying insert the function g of x into function f. In other words, everywhere we have an x in function f, we're going to replace it with the entire function g of x. So we're going to do the first one. This is going to be f with g of x is the way it's written. And what that really is the function of f with g of x inserted in. Okay? So now it's not too hard to do that. I'll come down and say, okay, this is the function of g of the f function of g of x. And to do that, I'm going to take my function f, and everywhere I have an x, I'm going to replace it with x plus 1. So this one says x squared minus 2x. So I would say x plus 1 in the replacement of that x plus 1 squared minus 2 times x plus 1. And now it's just algebra. Let's see if we can simplify some things. I know how to square a binomial. Square the first term, multiply the two terms together and double them, and square the second term. I'll distribute this negative 2. And now I'm going to do some simplification. I have x squared. I have 2x minus 2x, so that's gone. And I have 1 minus 2 minus 1. So that's my simplified function. Of course, you do recognize this as a difference of square binomial, but there's no need to factor it here. So now it's asking us a question. It's asking us to say, or maybe it didn't. I'm going to ask you this question. What would this function be for x equals 3? Well, all we have to do is take our final version here, and I'll write it in the composition notation. And it's equal to 3 squared minus 1, which is 9 minus 1, or 8. So we can answer that question. Now let's do the other one. Let's go the other way. Let's say we're saying the g with f function. In other words, we're going to reverse it. Really what that is the g function with the f of x function replaced in it. So I'm going to take my g function, and everywhere, let's see if I can write this again. Everywhere I have an x, I'm going to replace it with the f of x function. So where I have an x, I'm going to say this is really x squared minus 2x. The rest of that function is plus 1. So that's pretty simple. I don't have to do too much else with it. I don't have to worry about a domain here that's going to be an issue. And so I can answer my question, what would this function be, the final one, the composition function for x is equal to 3? Well, I just take my final function, g with f, and I substitute in a 3. So it's going to be 3 squared minus 2 times 3 plus 1. And that, of course, would be 9 minus 6 plus 1. And that would give me a 4. Now, how do we determine, and this is a little trickier, how you determine the domain of a composite function, of a composition? Now, so we assume the domain is any real numbers, of course, and then we exclude any x value that is not in the domain of g. That's the first thing, not in the domain of the second function. And then we have to exclude any output of the g of x, output of g, that is not in the domain of f. So let's do that as an example. See if I can focus this in better for you. First of all, we have to look at the two functions. We've got f of x and g of x, and we have to determine what the domain is. So I'm going to say the domain of f first. And it's going to be, it can't include a positive 4. So it's going to be negative infinity to positive 4, not including it, starts again above the 4 and goes to positive infinity. In other words, x cannot equal 4. So I know I'm going to have to exclude 4 somewhere in this thing. Now let's look at the domain of g. And g has just one problem. X cannot be 0. So I'm going to go negative infinity to 0. Don't include the 0. Start above the 0. Go to positive infinity. And I'll just make a note. X cannot equal 0. Now it said, my first rule, exclude any value that is not in the domain of g. Well, that means I have to exclude x equals 0. That's the first exclusion. Number 2, any output of this g of x function that is not in the domain of f, sorry. So I'm going to exclude, I'll just write it down here. I'm going to exclude any x for that g of x, right? For this function that produces y is equal to 4. I can't have that, right? It's not in that domain. I can't have the 4. Now, why did I say y is equal to? Because y is the output of the function, isn't it? That's what the output of the function is. The input is the x value. So I'm going to have to exclude any output of this g of x function that is not in the domain of f. Well, what's not in the domain of f? What's not in the domain of f is 4. Any output of g of x, any y of 4 is what would have to get excluded here. So now I just need to kind of figure out what that is. So I can say, since, and I'll just write it down, my g of x function is equal to 2 over x, isn't it? So therefore, where am I going to have a problem? Well, if 2 over x is equal to 4, that's my problem. So I can't have this. I'm going to figure out what number would cause 2 over x. What x value is going to cause that to be a 4? And I can do this several different ways. I can sort of reason it, and you may be able to see it. But if you can't, you multiply everything through by x. So I'm going to say 2 over x times x gives me 2, and that gives me 4 times x, which is 4x. I'll divide everything by 4. I get 2 over 4, or 1/2. What my problem would be, I have to exclude this number, right? So I'm going to say I have to exclude x is equal to 1/2, because that would cause an outcome, an output of 4 in the g of x function. So here's my restrictions on it. I have to say, I've got to have 2 of these issues, right? I have to say negative infinity, all the way up to but not including 0, right? And then I'll join that with 0, and I can go all the way up to but don't include 1/2. And then from above 1/2, just above 1/2, I can go all the way to positive infinity. And this, of course, should have been a soft bracket over here. Now, if you want to look at why this works, another little short way is like an explanation that might help you is this. Look at this like this. If I have the f with g function, then it's really f with f of g of x, isn't it? Which is really going to be my 3 over what? Well, 2x minus 4 is what I would put down. So what I've done is I've just substituted in g of x into the f of x formula, and I've got 3 over 2 over x minus 4. And I can see right here where I'm going to have trouble. I'm going to have trouble if I have division by 0. So I'm going to have trouble if this x is a 0. I'm also going to have trouble if this entire denominator comes out to be a 0. So in other words, 2 over x would equal 4. I've basically done the same thing that my 2 rules gave me, but I've just substituted it back in and found the solution, the same solution, a different way, if that helps you to see it. If not, then just follow your rules. I'll go ahead and write that out for you in case you want it. Here's where we would have a problem. We would have a problem if 2x minus 4 was equal to 0. So then we just solve for that. I'll multiply everything through by x, and I end up with 2 minus 4x is equal to 0. And if I take the negative 4x to the other side, I have 2 is equal to 4x. You can see the same solution happening. 2 divided by 4, which is really 1/2, isn't it? There's the problem. The other problem is obvious. It's right here, if x is 0. So I've got the same 2 restrictions that I had when I followed the rules. Now, one more question that students sometimes have is here. In the domain of f, we had to exclude x is equal to 4, but we didn't have to in our final solution. And that's because when we inserted the functions, 4 was no longer an issue. When we did the composition of functions, this one no longer had to be excluded. So that might be a reason that you want to keep these 2 rules in mind, and you exclude any x value that is not in the domain of g, but not necessarily any x value that is not in the domain of f, the first function.